First of all, string theory is an attempt at a quantum theory of gravity. The way that it works is, now I don't expect the layman to really appreciate why this is the right way to think about it, but let me try to explain it as best I can. In string theory, all particles, and particles means all matter, everything is made of particles, are made out of little loops of string. Little loops of string maybe that look about, well, forget these fingers here. So try to focus on the, here. They're made up of little loops of string. Now, in order for them to exert forces on each other, they have to be able to juggle back and forth these gravitons. What is a graviton? A graviton is another little loop of string. And so the way it works, the way that a juggler flips a graviton into the air is something like this. You start with a string, and that string breaks like that. Just breaks in half by splitting. And when it splits, it has effectively juggled a second string. And then this one might split and juggle. Well, your strings may be doing the same thing at the same time, and every once in a while, one of your split strings gets mixed up with mine, and we exchange it back and forth. And that's the origin of gravity in string theory.
So how big are these strings? How could I picture one?
Well, in the beginning, when string theory was first invented, when they were supposed to be protons and neutrons, a proton and neutron today, by today's standards, is a great big puffy marshmallow, big fat object. The strings that we're talking about now, which are replicas, or shall I say analogs of the same strings, are a billion times smaller. A billion times smaller than a proton.
A billion.
A billion, 10 to the 18th times smaller. So far smaller than we can see with any kind of microscope that exists, and that includes the world's biggest accelerators, far smaller than anything we can see, and very likely far smaller than anything we ever will see.
But it sounds like a very strange thing. Why would you imagine that the universe is built in that way?
Perhaps it may not be. But here's what we discovered. Sometime around 1969, for entirely different reasons, for reasons having to do more with nuclear physics than quantum gravity, people, myself included, began to explore what particles would be like if they were made out of little strings. And the reason was because we had experimental knowledge that protons, neutrons, the ordinary particles, had a string-like character to them. You could stretch them. You could spin them around as if they were bolos, the Argentinian bolo that the cowboy throws. There was experimental evidence of that type. And so people began to explore the possibility that particles are made up out of strings. What they discovered, somewhat to their own horror, I must say, was that these particles behaved as though they had gravitational forces between them, for exactly the reasons that I said. Split off little pieces, exchange them, and the forces that are created are exactly like gravity. And so accidentally, they discovered that in their best theory of protons and neutrons, it began behaving as if there was a gravitational force between the particles. And we've had no choice, really. We've had to track that down and follow it and find out what it means, find out why strings seem to lead to gravity, and we've more or less understood that. But at the moment, it is the only mathematical framework in which gravity and quantum mechanics coexist. And so we have no choice but to follow it down and track it down and see what it says.